Hey guys, I am super excited. After 4 months of painful waiting, it's finally here. What am I talking about? My Athena GET ECU for my KTM. Now, let me take just a step back and explain how I got to this terrible position. Back in January, I bought the new 2021 KTM 500EX CF. You all know that. You've seen my first ride review of the bike. You've seen my build video. Always intended with this bike to put an ECU and to do some exhaust work on it. And as I rode it, that intention grew even stronger because one of my main critiques back when I did the first ride video was that this bike flamed out really badly. So I always knew I wanted to put an ECU. In the build video, I talked about adding the ECU, I talked about adding the pipe. I've actually had this FMF sitting in my shop for 4 months back since I got the rest of the parts for the bike. I just haven't had an ECU to match it up with. I actually also ordered the ECU at the same time. Back then I was intending to get a Vortex, but unfortunately the global semiconductor shortage that everybody's heard about actually hit the dirt bike world right around then, and the ECUs were all on back order, both the GET and the Vortex. But like I said, I originally ordered the Vortex ECU at the same time as the FMF pipe. Unfortunately, it was out of stock. While I was waiting for that to come back in stock, Mike over at Pro-Moto Co. reached out to us on Instagram and suggested that I also try the Athena GET ECU. He told me that it's got a little bit of a newer chipset inside it, it has a little bit of an extended feature set, and that I might like that better. He also linked me to a video that Pro-Moto put out talking about some of the engineering behind the various pipe options, the endcap versus the FMF versus what's actually in the stock pipe. He does a little bit of a teardown on one and some kind of comparison between the Athena and the Vortex ECUs. I was intrigued by this information because there's a lot of detail in there that I hadn't really thought through. In my original decision to go with the Vortex, it wasn't really a principled decision. It was more like, hey, let me try this out. So Mike's pitch was basically, let's get you the GET ECU, let's get you to try that out, and then you make a decision about which one you end up with. Well, because of the chip shortage, I still don't have a Vortex on hand. That's fine. I've kind of given up on the concept of doing a comparison between the GET and the Vortex. What I'm going to do instead is basically try out the GET fresh and see how it performs in the bike, and then I am going to try a couple of different pipe options, and we're going to see which one works best for the kind of riding that we do here at Wannabes, and we're going to give you our recommendation. Because the stock ECU underfuels the bike pretty badly, there's a couple of things that happen. One is you get pretty bad flameouts. Now, side note on the flameouts that I've been having, I've been bitching about them since I did the first ride and the build of the bike way back in January and February. I've actually just recently, like in the last couple of weeks, discovered that the way the bike was set up from the factory, it originally had the idle adjustment set incorrectly. Now, this wasn't something that you'd typically notice. When the bike was warmed up, for example, it would idle just fine. However, it idled just a hair low, and bear in mind that it's already running lean because of the emissions requirements programmed into the ECU. So running it just slightly low actually was causing a lot of those flameouts because when you'd get on the throttle, it was just a little bit behind where the ECU intended it to be. So I discovered this because I was having trouble starting the bike, ironically, not with it running. Like it wasn't dying while it idled per se, other than the flameouts, which is where you'd go to get on the throttle, get a little too aggressive with the clutch, and it was kind of like a stall, except it was at a point where you knew there should have been enough torque in that engine to pull through. It's a big grunty bike. It should have been able to hit and pull through those, but it would die like without even pulling, to the point where I fell over the bars a few times because of it, really expecting the bike to go somewhere, and just you know, flop me right over the front. So the idle screw adjustment actually took care of most of that. So we're going to do this in stages. I think the right way to go about this is to install the GET ECU first and see how it functions with the stock pipe, the stock exhaust system, and all of the other smog implements still in place. We'll then move up to the Pro-Moto Billet end cap for the stock exhaust system. Now, this is what this looks like. I'm pretty excited about this because this leaves your stock pipe in place. I'm pretty hard on my bike. You may have seen me loop it out periodically, which happens more than I'd like to admit. And having the stock pipe in place, I think, is just, it's a good thing to sort of bang up on without worrying too much about it. It's supposed to give you a good sort of balance between that top end power and more of maintaining more of like a mid-range for trail riding and some of the slower technical stuff that we do. So we'll see how that plays out in practice. That's sort of the engineering angle, but we'll try that out on the trail and see if we can really notice that difference. Of course, with the end cap, we've also got this downspout. And what that does is direct some of the flow out of the end of the pipe down towards the ground a little bit, and that's really just to dampen sound. I think you don't want that sort of shotgun rumble firing back at your friends. Not sure if I'll care that much about it. I don't think that this is going to restrict very much. It's got a ton of holes in it. It is going to slow the flow down just a little bit, but again, running this end cap, you're not at full flow anyway, and I'm not sure that's going to make much of a difference. One quick note, I highly recommend that you run a spark arrestor. They're optional with all of these components. They're required though on OHV trails and in the state off-road vehicle parks, and it's just the responsible thing to do. Anybody who lives in Southern California or some of these other Western states, we're in drought season. It's been a dry year. Even when it's not, forest fires are a major problem in this area. We've all seen those and their sort of nasty side effects. Run a spark arrestor. It's a responsible thing to do. I've also got one for the FMF pipe, by the way. They just don't restrict flow in any meaningful way. You're not losing anything, and you're making the whole environment and the rest of us much safer. So do the right thing there. Now, let's check out what's in this ECU box. Now, these components are kind of cool. So Takamoto sent me over the kit with the switch, so that allows you to switch between a couple of different maps, and you can choose which ones, I think, in the settings somehow. Here is the magic piece itself. Pretty excited about the way this looks. My understanding is that it's plug and play, and you adjust it through like a Wi-Fi app. We will get into more of that as we get into installing it, but that's what it looks like. It's also come with some other accessories. I think that has to do with some smog modifications. And then finally, I've had sitting in my shop for just about forever, this FMF 4.1 pipe, which I'm pretty excited about because it's an excellent looking pipe. And I think that there's certainly like a fun factor to putting these pipes on your bike in that everybody knows that you've gotten serious about doing some modifications when you run these. Of course, a lot of guys put them on there without actually being that serious. The interesting thing about these is while they'll open up flow, with the stock ECU still in the bike, you're really not getting any, the stock ECU just doesn't have the fuel mapping to be able to inject additional flow. So or additional fuel to match that additional flow that you open up with the FMF pipe. So putting the pipe on there by itself, if anything, is just leaning out the bike, probably has very little impact at all. So that's why I've had it sitting in the shop and not actually used it for so long, because I've been waiting for that ECU to come in. Finally, I also got this little smog delete kit. This is actually for the O2 sensor that's on there. With the Vortex that I originally ordered, the O2 sensor is not a part of the loop, and so putting that little plug in there will get that expensive part out of the way so you don't damage it. So we're gonna run this in sequence. We're gonna put the ECU in, we're gonna see how that performs on the trail and on some hill climbs. We're then gonna upgrade to the end cap. We're gonna try that out, doing some of the same trails and same hill climbs, and we'll then jump to the full FMF pipe, and we're gonna try to pick between those three sort of options or configurations, if you will, and figure out which one works best for the kind of riding that we do, and we'll give you our recommendation on that. Let's go get the GET installed. It's a pretty simple procedure, but it's gonna take me a few minutes. I've gotta pull the seat off the bike, and in order to run the map selection switch, I've also gotta pull the tank so that I could route the wire from the handlebars down to the ECU location, which is down here under the seat. I'm going out riding tomorrow. I'm doing about 100 miles up in the Big Bear area, and I'd really like to get the first stage of the test with the ECU out of the way. So I'm gonna be running the ECU by itself with the stock pipe in place. I will be capping off the O2 sensor, and I will be doing some other hose changes to some of the vent tubes and things like that kit that came with the ECU that I ordered. But I will not be doing anything to the exhaust, so we will not be at full power. I'm looking here mostly to see how some of the more restrictive maps work, the less aggressive mapping, particularly map 2, which is a Takamoto map that sounds kind of interesting for a more adventure riding type setup potentially. We're gonna do some hill climbs tomorrow, we're gonna do some trail riding, and it'll be really interesting to see how the ECU performs just as an ECU without any modifications to the exhaust system or the airbox or anything like that. And then of course next week I'll get in and we'll get the Billet Moto end cap put on the stock pipe, and we'll continue the testing from there. So let's get this part installed. Like I said, taking off the seat, taking off the tank. It's really straightforward to clip this in. I'm not gonna go into a lot of install detail. You basically unplug the existing ECU and plug this one in its place. I'll link to the Takamoto video on how to get those installed. I think they've done a really nice job with it, covered it much better than I could. So we're just gonna kind of fly through this part of it, and then we're gonna get out on the trail tomorrow. We're gonna see how the ECU performs with the stock setup for the exhaust system. I'm in the kitchen. When you Uh-oh, you and me both. Go for it. You're good. Yeah, I just put a new ECU. I put the GET in and just getting used to it. So I just had like crazy issues starting it, and I flipped to the other map and it finally got going, so that's something to think about. I don't know what was causing that, but good thing I got lots of battery life in this. Got a lithium battery in here, stock. We're back in the shop after an excellent ride yesterday. We did about 75 miles of dirt from Phelan to Arrowhead and back, so a really good opportunity to test out the ECU without any exhaust modifications on a combination of different terrain types. We had some fire roads, we had some single track, we had some technical stuff where we were climbing over some rocky sections, and I really got a good sense for what map 2 will deliver. It wasn't until the end of the ride that I started flipping over to map 1. Now what happened was a couple of times I really had difficulty starting the bike with map 2. This is the Pro-Moto custom map. It would crank just fine, it would start up, and then it would immediately die. And one time it got really bad, I actually couldn't get the bike started, so I flipped it over to map 1, fired right up, and off I went. I flipped back to map 2 after that and ran that for a bit. A couple of highlights of map 2. It'll give you a much better throttle response than the stock ECU. It will also give you a lot more low-end grunt. So there's a few times where you're really lugging the bike, and with the stock ECU, it'll flame out. That's why I called it the king of the flame outs when I first reviewed this bike. With the GET ECU running map 2 from Pro-Moto, that problem is just about solved. You get that real low-end thumper grunt that you'd expect from a 500cc bike, where it's just thump, 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 and it just keeps firing and keeps pulling. And that's really nice, because sometimes when you're lugging it and you get into some technical situations and you're trying to pull through, I've had the bike with the stock ECU flame out and toss me over the front of the bars when I was expecting it to get up and go. With the GET ECU, you can still stall the bike, of course, but it's a lot harder to do. It's a lot more grunty on the bottom end. And once you get up into mid-range, there's a lot more throttle response, meaning as you hit the throttle, it comes on stronger and faster. So I really liked all of that. What I didn't like so much about map 2 was at very low throttle angles, like nearly closed, it tends to surge. I did the analog procedure for zeroing the, for setting the TPS position sensor. So that's where you don't start the bike, but you hit the starter, you let the fuel pump spool up, you turn it off for 7 seconds, and you turn it back on, and you're supposed to be good to go. I actually reset that in the middle of the ride yesterday because I was having trouble getting it started, and with that sort of loping at the bottom end. But what's interesting is map 1, which is the more aggressive map, didn't have either of those problems. I never had any issues starting it in map 1 once I flipped over to it towards the end of the ride. And I noticed that loping or sort of surging at the bottom end disappeared. So that tells me that it's probably not the TPS, because if it were, I would expect it to affect both maps equally. Could be wrong about that, but it seems to me like something in the map settings. So I'll do some more research there and see if I can get you guys an answer on that. It's kind of a deal breaker, map 2, really, you know, the issues I was having with map 2, because there's just no good way to ride the bike with it loping and sort of acting weird at very low throttle angles. And of course, if you can't get the bike started, you're out of the game. So yeah, not real excited about those technical issues with map 2, but otherwise really enjoyed the performance of it when it was up and working, especially higher up in the throttle range. Map 1, I didn't have a ton of chance to try out. I did notice sort of initial impressions of map 1 on the ride back yesterday was that it's much more aggressive than map 2, which makes sense. It's sort of the full-throated, all-power map. Now, I didn't start running it initially because it's really designed for setups where you have the full exhaust or at least the end cap, which we're going to be installing today. And because I didn't have that on the bike yet, I didn't think that was sort of the most appropriate map to give me the best first impressions of the GET ECU. That's probably still true, but I was surprised at how well it ran on map 1, even without any exhaust modifications. It seemed to run great, probably overfueling the bike at that point, but I noticed that it's much more aggressive, where map 2, they have something called traction control, which, as I understand, kind of softens the throttle response in the low part of the rev range, or maybe low throttle angle. I'm not sure which one they're using there, but I noticed that map 1 was much more aggressive all the way from very low throttle angles all the way up. So as soon as you hit it, instantly starts to rev the bike out and deliver real power, really aggressive. It also means that when you chop the throttle, it's a little bit more aggressive, it seemed like, in closing things down. And so you can get a little bit of that throttle lurch where, like, you know, you're sort of throwing your weight back and forth because the bike's jerking, especially in low gears. But that's all stuff. If you're a decent rider, you'll have good throttle control or clutch control. Most of the time I'm not running in first gear anyway. That's really like, you know, I'm gonna jump over this log kind of a gear or something. So that's all on me as a rider. What it tells me is that that's an aggressive map that gives me the power and the control that I want as a rider who is trying to figure out how to be better with the bike and not just sort of give up control to the ECU. So I really like that about it. Certainly map 1 is designed for a more open exhaust, which is the mod I'm going to be doing today. So at this stage, I'm going to be removing the stock end cap from the stock exhaust pipe, and I'm going to be installing this Pro-Moto Billet end cap with a spark arrestor. I'm then going to do a sound test. I got this little downspout as well. Pretty sure that's really just for sound. It's to direct the sort of exhaust pitch down towards the ground a little bit. So I'm going to do a sound test, stand behind the bike, rev it, try some stuff out. I'll show you guys what that sounds like or looks like. And we'll see if that's a part we want to leave on there or not. I don't really think it's that much of a performance component in either direction. I don't think it impacts performance really at all. I think it's really more for aesthetics. So we'll get this on today. Won't have a chance to ride for a few days probably with this on, but we'll pick up once we finish the install of this. We'll show you guys how to put this on. Then we'll pick up next week probably with a ride test of the Pro-Moto Billet end cap in conjunction with probably map 1 of the stock ECU, especially given the issues I was having with map 2. I think I've pretty much moved on from that. The whole point, I'm not doing this mod to sort of tame the bike or put 87 octane gas in or any of those kinds of things, some of which map 2 will give you. I really want performance out of it. I want a race bike out of it. So I'm thinking map 1's probably, I mean, it's almost certainly where I'm headed. So let's show you guys how to install the end cap, and we'll go from there. So you can see this dam here spreads the airflow as it comes up out of the pipe. It's going to hit that dam and it's going to have to spread and then get back through this spark arrestor, and that's where you get most of the restriction in the stock pipe. This is also a pretty small outlet size. The outlet here is real small. You can see here's the volume, the diameter of that inner tube. That's where your exhaust is actually flowing. This is all just sound damping. So your exhaust is flowing there, and it drops down quite a bit before it can exit the stock cap. Okay, so we've got the end cap put on, the spark arrestor's in there. I will give you one note of caution. These self-tapping screws that Pro-Moto provides to tap in, so you drill out holes in this to match your stock holes, and then you run these self-tapping screws in. They're an Allen key style, and they strip out extremely easily. So just about every one of these is partly stripped to get them to actually tap through the aluminum. The Allen key, even the properly sized one, is turning in those, so that's pretty annoying. It's really not big enough, I guess. But the rest of the install went fine. The spark arrestor's in there. So what we're gonna do now is start the bike up, and we're gonna listen to what this sounds like, because what I'm trying to decide is if I wanna leave it open like this or put the downspout in. I definitely like the tone of that. It sounds a lot like when you've got a pipe on the bike, you've got a much straighter shot. This end cap is pretty much a straight shot down the length of the pipe. There's no turning, there's no downsizing or anything else that happens like with the stock piece, so that's pretty cool. Because this downspout, you know, has these waffles, there's quite a bit of air passing through those, plus through here. So you don't lose that much volume, but it will muffle the sound a little bit. So let's put that in there and see what that sounds like. Definitely directs the flow down this way quite a lot, which is pretty obvious from the shape of it. You're not shooting straight back. So I actually think I don't like the tone of that. It's really fairly close to stock in terms of the volume that it's putting out. A little better of a tone, but I think that taking that end cap out gives you kind of that cooler throaty pipe sound, which I kind of like. A couple of quick things about doing the end cap installation. Because you're getting into the packing of the original canister, there's a lot of insulation in there. I deeply regret not putting a pair of gloves on to cut through that insulation. I've got all kinds of insulation fibers biting in my fingers. I can't tell if they're just cuts, you know, you get those micro cuts, or if there's actually like slivers of insulation stuck in my skin, but it hurts, it itches. I've done enough construction. Absolutely knew better, but I thought I could pull it off because I wasn't touching it very much or something like that. Honestly, I don't know. I was an idiot. Even though, you know, I'd love to go back 5 minutes and yell at myself. So I'm gonna yell at you instead. Put some fucking gloves on. It's not that hard, and this stuff hurts like hell. So this stock piece is actually really restrictive when you took a look at it. In addition to the dam, it downsizes quite a bit and it turns. It's also got a secondary screen out here on the end that cuts the flow quite a bit. It does muffle the sound a bit, but I don't think that the Pro-Moto end cap really turned the volume up that much. I mean, it's louder. I'm sure if you measure decibels, it's a little bit louder. But what you really notice is the throaty, deeper pitch, the tone of the pipe, not so much this total volume. Like, it's not all that loud really for a dirt bike. But it just has a much deeper sound. It sounds like a big bike, like a 500. Sounds like a race bike, which I like. So I'm pretty excited to get out on the trail and give that a shot. We'll see how the ECU plus the end cap do next weekend when we get to go riding. We'll put that through its paces and try it out quite a bit. We'll let you guys know what we think. We'll be back shortly.
Yeah, you're right. Like, you get the grunty torque of a big bike, but this gives you some of the rev back. Like, it's gotten real peppy. I noticed that without even the pipe on, but like especially map 1, it's just like, it's aggressively revving. It's amazing. And since it makes so much power, you have like boatloads of power instantly at your disposal. You just flick it and it's like suddenly a monster. Oh yeah, it's quite thrilling. I think I'm gonna have good things to say about the GET and the pipe combination. I'm not even sure it matters which pipe, like, just do something. See, so this GET, even in like map 1, which I thought was better, when I first start it sometimes, it starts and it like overfuels and then I feel like it backs off or something, and there's like a catch. And if you start it like right back to back and kill it, I think it floods. And when it has that like catch where it like almost stalls, it actually stalls, and then you're like flooded out and can't start it. So I found you have to like back off for a minute. I found, like, I'm not sure what fixes it, but I've switched the maps, let it sit for a second like if it was a flooded carb bike, and then try again and it'll come back to life and kind of sputter. It's very, like, I'm pretty sure it's flooding out. So, I mean, it's just something I think, like, just to be aware of, that you can flood it out actually, and that's like something to keep in mind. It is ridiculous. Like, so, you know, I run the bike geared down, and so third gear is like a decent trail gear, but lots of the time it's like mid-range, so you're lugging it. It's like middle of where you want to be. So lot of times you're lugging it a little bit in third. But with this pipe ECU combo, the lugging is gone. And when I fucking peg the throttle, even from like very low RPMs, the bike gets going so fast that before it has a chance to like bog or anything, it spins up and it hits like you dumped the clutch. So like, I think like, I don't know how else to explain it. It feels like a clutch dump, like it hits and like yanks the bike away. And because you're running in a high gear, that hit has like a lot of wheel speed associated with it and you launch off. So like coming off these whoops, for example, I'll leave the clutch out and just punch it, and it'll like, it spools up so fast and pulls so hard that even from like the very bottom of third, it'll like rip away from you. It is like it's a badass experience. I'm pretty stoked. Yeah, right. It just like hits, it spools and hits, and so it makes tractoring in third gear like very doable with less fancy clutch work. Yeah, I'm pretty impressed. Changes the whole bike. They're not kidding when they say it unlocks the bike. Like, that's absolutely true.
Hey guys, it's time to take the last step in this exhaust system journey and throw this FMF pipe on there. I've been running the GET ECU with the Pro-Moto Billet end cap now for a couple of weeks. I'm very happy with it. I want to say right here, before we do any kind of final conclusions or anything like that, before you've even tested the FMF pipe, that it would be very reasonable if you're trying to do a build with exhaust and the ECU to stop with the end cap and call it good. The performance is incredible. The pickup on the throttle is just fantastic. I really can't say enough good things about it, but because you guys are paying me for this, actually wait, you're not. You know what, fuck it. Just kidding guys, buy them out. Because you guys are paying me for this, I'm actually gonna go all the way. We're gonna try out the FMF pipe. I'm honestly not sure what to expect. I'm not sure if I'm gonna like it or not. I'm so excited with the way the end cap on the stock pipe is working out that, you know, I may end up back here. One quick thing, the FMF pipes do not come with the spark arrestor built in. You can add one, they have one. Please run one. I know I keep saying that, but please do that. The pipe's really easy to install. Goes in just like this, sits right on where the existing pipe goes, mounts up to all the same holes. I will say the FMF pipe weighs half as much probably as the stock pipe, maybe less. So that's gonna be kind of a cool thing. Also looks way cooler. Stock muffler, seriously heavy. So this just slides on, same way the old one came off. Okay, let's start this bike up and listen to this pipe. Kind of excited. It's quite a bit deeper still than the end cap was, and I was pretty impressed with the end cap. Yeah, that's a rumble. Before I get this pipe hot, I'm gonna get the spark arrestor installed. So the spark arrestor sits inside the pipe just like that. These metal screens catch the sparks and prevent wildfires. We're gonna slide it in, and then we've got this kind of locking ring that we actually screw into place in front of it. So we'll slide this in, and if you spin this in reverse, you'll expand those rings and seat that groove. And then finally, they've got this spark arrestor approved sticker. So we're gonna slap that on right up here with we'll clean the spot with an alcohol pad first.
The pipe delivers just fine in this stuff. Yeah. I have no power problems. In fact, that whole thing that you need to like preserve mid-range is bullshit. Because when you're doing this, you don't need mid-range. You need it to fire fast. Like you get in, you hit like a dump, you know, like a you bottom in between rocks or something, and you got to launch the front end and clear. It's not about fucking mid-range. It's about when you hit the throttle, it explodes and goes. Even in the slow shit, like you still need that like explosive power. I mean, it's the whole point of a two-stroke is that you get that revier delivery. Yeah. Yeah, exactly. You punch the throttle and use the clutch to control if it goes wild, which it has a shitload of power. Right. So yeah, if you wanted to throttle through, maybe, because that would get hairy with like having to rev it. But with good clutch control, you want it, you're revving it out anyway, so. Yeah, I think it delivers. That's fucking cool. Low, cold, that's what I did. And that was perfect, because once it gets warm, it seems really nice. And it's not stalling out. Like, I flamed it out one time in all those rocks when I just cold started it after sitting for a while and then, like, hit a rock. And I didn't give it enough gas, and it was idling low because it was cold. But otherwise, through all of that, like, I didn't have any trouble stalling it at all. Like, it would keep running even when I dumped it sometimes, which sometimes it would flame out when I did shit like that stock, so I'm pretty pleased. Yeah, it was really bad. It was really bad with the stock ECU and like way off idle. It was unrideable. I don't know how they sent it home to me that way, like they're supposed to set it up, but I feel like this whole bike, it's kind of a cool thing. It's like a 6-month like experiment in how to get like a top bike. And I haven't done like any, you know, I'm not like into the valves or changing out the bore or anything like that, which that's like a whole other level. Right. I'm not trying to do that. I'm trying to get like the stock bike to, well, I guess that's not quite fair either. But like to unlock it. Right, exactly. That's exactly it. So yeah, like you start doing cams and valves and bores and stuff, and you I'm sure it can be done well, but I feel like there's also a risk of you kill your sort of longevity and reliability. It becomes much more of like a hobby and like, yeah. As much as I appreciate being a capable mechanic, I would rather ride than sit there and fiddle with it all day. Like, I don't do the mechanics for their own sake. You know, it's just like nice to know to get the bike back on the trail.
All right guys, we've jumped into the classroom really quickly to understand some of the physics behind how exhaust flows through your engine, because I think that understanding the mechanics will help you understand the components better, which will better help you make choices around what's going to work for you. So let's dive in. This is a little bit complex. I've tried to break it down in sort of layman's terms, but there's some complex concepts here. You're welcome to go read about it. I'll maybe provide some links to some of the reference material that I used in getting to understand this. But please feel free to watch this a couple of times and hit us up if you have questions. It gets a little bit complex. One thing that I want to preface this by saying, this is for 4 strokes only. I know absolutely nothing about how 2 strokes work. As far as I'm concerned, they're like valveless magic, is some kind of wizardry that I know nothing about. So maybe we'll learn that in some future video. But this is the exhaust flow of 4-stroke engines, particularly dirt bike engines. So here we have your basic components, right? We've got an ugly little drawing of an engine. Here's your cylinder space, your piston, your valves, your exhaust header flowing into the muffler. And we'll talk about that guy in a second. So everybody understands the basics, I think, right? That air comes into your engine, some gas is squirted into that air, it mixes, it fires, an explosion results, and you get exhaust gas that's left over afterwards. Now, something has to be done with that exhaust gas in order to clear out the cylinder, to intake new air and start the process over again. We know that the valve lifts on the exhaust side during part of the cycle. The piston comes up, the exhaust gases that are in that cylinder are evacuated into the exhaust pipe and flushed out into the atmosphere for all of us to breathe. There's a lot of myths around how various pieces of this puzzle contribute to engine performance. So let's go through and talk about exactly what each piece of this system does. The piston, of course, is what you drive by the explosions, but the piston also returns some effort into evacuating the cylinder chamber, and of course into compressing everything when all the valves are closed during that part of the cycle. The header pipe is going to take the exhaust gas off the engine, and the size of the header pipe is going to dictate the velocity of the flow of an exhaust slug. So every time the piston fires, you have a certain volume of exhaust gas that's expelled out the valves and is going to have to travel out the pipe and out into the air. That's called a slug, and it looks something like this. It's got a high pressure front, and the pressure on it decreases as you move towards the tail. This pressure on the front has to be enough to overcome atmospheric pressure and push its way out through the pipe, which is filled with atmospheric pressure air. Because it's like a moving piece, it's got some inertia to it, so the front of that kind of wave is going to have a higher pressure zone. The pressure is going to taper off. At the back of it, the pressure actually drops to 0 and you have a small vacuum. Now that vacuum is an important part of the puzzle, because as this slug of exhaust gas with its trailing vacuum at the tail end is leaving out the exhaust header, that vacuum tail is actually going to help suck out whatever's left in the cylinder at the end of the cycle. That's called cavitation. Now that cavitation is important because that clears room for the piston to come back up without hitting any resistance. If you don't have that cavitation, what you end up with is you will still clear the cylinder because the piston mechanically comes up and shoves everything out of it. That's okay, except that the piston then has to do some mechanical work to empty the exhaust out, which means that mechanical work has to come from somewhere, and effectively that's going to reduce the efficiency of your engine, and it's going to reduce the power output because it's consuming some of your engine's power to do that mechanical work. So this cavitation principle is really important. Now this cavitation happens if and only if that slug of exhaust gas is flowing at a sufficient velocity, speed, right? So if it's going too slowly through this pipe, it's not going to create that little vacuum pocket behind it. It's not going to create cavitation, and you're going to have reduced performance. In order to get it to flow at the right speed, you control the shape and size of the exhaust header pipe very carefully. Now that's something that engine manufacturers spend a lot of time engineering. There's no universal pipe size that's perfect for all engine speeds. So what they do is design a header pipe that's got good flow characteristics or acceptable flow characteristics across a wide range of engine speeds, engine RPMs, right? So you have low-end performance and high-end performance and everything in between. Once the exhaust gas leaves the header pipe, all of those characteristics of those slugs of exhaust gas have already been created. So while it's terribly important that your header pipe has the right size for the volume of engine that you're operating and for the engine RPM speed range that you're running in, once everything leaves the header pipe, you can see all these red arrows represent the various slugs that are on their way out of the exhaust system. Now remember, your engine's firing several times per minute, so you're going to have hundreds of these slugs in the exhaust system at any one time, and they're going to be flowing out. But by the time they get to the muffler, They're basically just on their way out the very end of the system. Now, this is where we get into a couple of the myths around how exhaust systems work. Because a smaller pipe for the same given volume of exhaust gas is going to create higher velocity, higher speed travel. You have less distance, same volume and pressure, the speed has to go up, right? There's those variables. And a larger pipe is going to create a slower slug. To get this cavitation, you're going to design just the right size of pipe, not too big and not too small. Now, I think what happened in sort of the general ether of how exhaust systems work, the common perception is that because pipe size matters here at the header, pipe size must also matter at the muffler, and that you can use the muffler's pipe size to impact some of the performance characteristics of the rest of the system. Unfortunately, that's generally not true. There are some exceptions, and we get into some really deep physics to where that matters more if you're running a turbo and all sorts of stuff, right? But in your basic motorcycle engine exhaust system, by the time the exhaust gas reaches the muffler, all of its characteristics are already set. The only thing that the muffler is actually doing for you is absorbing the sound that's coming out of your engine. If you take the muffler off, obviously you have the best flow characteristics because you've gotten out of the way of these slugs that you want to expel from your engine, but you have a ton of excessive noise. It's not legal, and it's not even comfortable to ride a bike like that, right? They're ridiculous. So we put a muffler on, and a muffler is basically this same exhaust pipe, but it's like double layered, and in between they have a wrap of glass insulation that absorbs the sound waves that are coming off of these slugs of exhaust as they travel out of the system. And that's really the only job the muffler does. Now, there's also something called a resonance chamber, which is that little sort of bomb looking thing that you'll sometimes see on 4-strokes. Somewhere up in the header pipe. Typically what that does, it's carefully engineered to actually create canceling sound waves, so the waves will flow back and forth through that resonance chamber in such a way as to actually cancel each other out. So it's really just to either change the note or reduce the total volume of sound that's coming out of the bike. But what happens when you have a resonance chamber like that, or if you have a muffler that restricts flow, is all of these slugs of exhaust. So let's say, like here we have the stock exhaust, right, with kind of a smaller opening than an inlet. These slugs have been traveling at a certain velocity, at a certain speed, right, given the size of the pipe that they're flowing through. If they then get here and they're restricted from exiting, they're gonna start to pile up, right? And you're gonna get these extra slugs. You're gonna also get some back waves as those hit the end and reverberate back. And you're gonna generally build pressure, a little bit higher pressure inside that pipe, or that muffler. Now that pressure obviously is going to, over time, these slugs are going to start to pack in there, and you're going to have that impact the flow all the way back into the engine and ultimately into the intake system. The engine cannot draw in more air than it can expel out the exhaust system. So for maximum performance, you want to be able to bring in as big a volume of air as possible, mix it with as much fuel as you can stand, obviously in the right ratio, and then expel it as fast as you can out of the engine. So when you have a restrictive exhaust system, all you're doing is slowing that entire system down, right? So this is what's generally known as back pressure. It's not actually back pressure. There's not actually pressure pushing back into the exhaust system. If there was, you'd push stuff back. I mean, the exhaust would flow in reverse if you had back pressure. So it's not actually back pressure. That's kind of a misnomer. But what back pressure means is a resistance to the flow of these slugs as they leave the exhaust system. Now, where people get confused is they interpret the mechanics of the header pipe, which shapes the size and speed of those slugs, or the characteristics of those slugs, with performance at the muffler, and they assume that changes you make to the muffler are going to impact the beginning of the system, which is actually not at all how it works. There's no back pressure that you create. What you do by restricting the flow at the end of the muffler system is you actually grab each of these slugs, you slow them down, and you pile them into each other, and you ultimately slow down the entire system. That's the only thing a muffler is ever going to do for you. There's no case where the muffler is going to impact the performance of the engine in a positive way. It's just not how it works. These slugs are shaped by the header. If the header pipe is designed properly, you'll have proper cavitation in your engine, and you need to get those slugs of exhaust gas out of the system. Once they're shaped by the header pipe and they're on their way through the system, you basically want to get them out of the way as much as possible. Anything that you do interferes with their flow and ultimately interferes with performance. The idea that you're going to restrict their flow way up here by putting a restrictive muffler like the stock muffler pipe on the KTM that I'm running, for example, and improve performance is just simply not how the physics of these things work. So what happens when we upgrade our muffler is we actually take off this restrictive end. We get rid of all this turbulence that we create in the flow of exhaust leaving the pipe, and we get these slugs that can carry on their merry way out into the air without any restriction. And we get to a point where we're creating the maximum flow characteristics or capacity of our engine. So we're drawing in as much air as possible and expelling it as quickly as possible, with the header pipe still maintaining the characteristics of the slug that create that little vacuum pocket that pulls everything through the system. Which leaves us with this whole discussion about what happens to mid-range torque and small pipes and back pressure for low-end torque, right? And open pipes for high-end horsepower. Well, none of that is actually true. As I said in the beginning, the size of your header pipe dictates how these slugs behave. But the header pipe is designed for kind of a wide range of engine conditions, so it's not perfect at any given RPM. Whatever the engineers had in mind with the bike, that's what they built the header pipe to do. But the header pipe does all that work. If you're changing the header, you're gonna need to get into some of this stuff, and you might need to do some math to figure out what kind of header pipe's gonna work better for some particular characteristics. By the time you get to the muffler, all you're doing is either letting the exhaust gas out or getting in the way of the exhaust gas. If you're getting in the way of the exhaust gas, you're never going to improve the characteristics of your engine. There's no muffler that's going to give you better mid-range torque here at the engine. It's just not how it works. All you're doing is damming up this system. This idea that you need like pressure, you need to slow this whole thing down, it all comes from this velocity characteristic, which is the size of the piping. It dictates the speed of those slugs, which dictates the size and characteristics of the vacuum pocket that follows them. But all that's done by the time you get to the muffler. So I don't care what type of engine characteristic you're looking for. The theory says that a muffler has zero impact on what happens way back here, except if it gets in the way of the flow of exhaust, it can potentially slow the whole thing down, right? So you can lose power from a muffler. You can get power back from a muffler by opening it up, but you're never gonna move the torque characteristics up and down the curve, and you're never going to add more power than your engine originally was capable of, except for the fact that you got out of the way of the exhaust if you use a more open muffler. I think another thing that happens is built on this myth of how the physics of the exhaust system works. People add another layer, which is their trail experience, and I think what happens is when you open a bike up like this, like the KTM 500 that I'm riding, for example, you get a lot better throttle response, which means the bike revs more quickly. It also puts more power down to the wheels. So a couple of things can happen. If you're not very comfortable with aggressively getting on the clutch or aggressively getting on the throttle, that power characteristic, that power delivery can tend to surprise you. Even knowing how it's supposed to behave, I have sometimes gotten into situations where I've punched the throttle and had the bike jump more than I've thought. And I think what's happening on the trail is a lot of guys are confusing having a more sluggish engine response and therefore an easier time accessing some mid-range power with what happens when you get a full pipe on like this and you punch the throttle and you have the bike rev out and jump. They're getting performance, but they're misinterpreting the performance because they're having trouble controlling it as poor characteristics of the engine. So that's kind of a convoluted explanation, right? But if you're out riding gnarly rocks and you punch the throttle and the bike jumps away from you, you might think that you're missing that mid-range torque, and that's why you weren't able to put down the sort of appropriate amount of traction that you were looking for. What's actually happened is you put too much power down because your bike performed better than you expected it to. And because you put too much power down, the bike jumps away from you. The thing to do is either control that through how you manage the throttle or use the clutch to bleed off that extra power, or some combination of the two. It's not actually that you're missing mid-range torque. It's that you've actually improved the throttle response of your bike to the point where for the same amount of throttle application, you're getting more rev out of the bike and more power delivery to the ground. And in some cases, that might not be what you want, right? If you're slowly crawling over the rocks and you want to put a little amount, like a small amount of power down to just sort of bump you over the next obstacle, revving the shit out of the bike and having it jump away from you is probably not what you're looking for. So there's definitely a place where using the sort of lower side of the power curve of your bike is applicable to the riding that you're doing, but it's not actually coming from this setup, except to the extent that if you're running a more restrictive muffler, you won't actually have access to the like too much power side of the power curve, and you'll have less opportunity to accidentally over rev the bike. So it has more to do, I think, with how you manage the throttle and the clutch versus traction than some kind of like mid-range torque that is or isn't there. In all cases, the mid-range torque is there. It's just how fast you rev through the range and how much control you have over it as you're revving that bike out. Hey guys, we are back in the studio. It's been a couple of months putting this video together. We have done a ton of riding in every different kind of condition we have available to us at this time of year. And I'm sure you're all dying to know what I really think about the various pipe and ECU options that I've put up. I ran through every single piece of these components one at a time to figure out what I liked and what I didn't like about each piece. And I want to give you guys my recommendation, but just real quick, let's recap what we've been through. We started with just the GET ECU in the otherwise stock, exhaust stock bike. We then moved up to the Billet-Moto end cap by Fastways on the stock KTM exhaust pipe for the EXCF models, replacing the stock end cap. And from there, we moved to a full FMF race pipe, the 4.1. And I'm pretty excited about actually every stage of this process, of this experiment, because from day one putting the GET ECU into the bike, I began immediately to notice differences, and I've noticed different characteristics and different things I liked or didn't like about each stage of the process. So if you get the bare ECU, you will take care of some of the lean conditions that this bike is normally kind of tuned for. Unfortunately, because of smog requirements and other stuff, engine longevity, whatever the case might be, the bikes are tuned really tame. And so putting this GET ECU in is going to map proper fuel into the bike, even with the stock exhaust components, and you will see some difference. Mostly you'll see a little bit better throttle response, a little bit easier starting, caveat on that, except when you flood it. And you know, it's just a better running bike in general. But I really don't think that the GET ECU by itself, without any exhaust modifications, is worth the money. It's a pretty expensive component, depending on where you get it and how much you add on to it in terms of like the Wi-Fi module and the switch and some other optional components. You can easily spend, I don't know, $1,200 or something like that with everything in, I think. You know, that's a lot of money for like slightly better performance that you may or may not notice depending on how aggressively you ride. So I would not recommend getting the GET ECU by itself. It's a racing component. It depends on an entire system to function properly. And if you don't have that full system in, you're basically tossing a ton of money into a fairly minor component. I'd say take a class or just spend a few more hours riding, and you will get performance out of yourself that's much bigger than the performance you'll get out of the GET ECU by itself. Now, not a slight on the GET ECU, that's not what it's made to do. That is, it's not intended to be in a stock bike by itself with no exhaust modifications. So obviously not gonna be, you know, they didn't intend for there to be a gain there, and you won't see one, honestly. Nothing that justifies the money. The next step in the process I went to was this Fastways Billet-Moto end cap. That opens up the stock pipe quite a lot. The stock end cap has this flow dam on the end of the spark arrestor, on the inside end of the spark arrestor. It also downsizes the tube quite a bit. So you really have a lot of restriction on that stock end cap, and taking that off and getting an opened end cap, still with the spark arrestor, of course, is going to make an enormous difference. Because I flowed through this whole process from the GET ECU to the end cap to the FMF pipe, the biggest piece of the jump I saw came when I started to open up the exhaust pipe by putting the end cap on. I probably got, I'm estimating something like 75–80% of the performance gains of the end system by putting this end cap on. It's a very rideable bike at that point with a ton of really aggressive throttle response, really nice pull through the RPM range, a lot more power that's immediately obvious, and a really nice exhaust nose. So a lot of really good things, a lot of great stuff to like about getting the Billet-Moto end cap on there. And I would say if you're on a budget, the end cap, I don't know, it's $150–200, something like that. It's a lot cheaper than FMF or most other aftermarket pipes. And if you're on a little bit of a budget, I would highly recommend getting the GET ECU and then getting some kind of an end cap like this one to stick on your stock can, and off you go. Like I said, you'll get probably 75% of the total improvement that's available, and you'll do that on a pretty substantially reduced budget. Now, if you want to go all in, go with the FMF or similar pipe. I don't really care if it's FMF or not. I have no affiliation with them. I haven't tried other pipes just because I don't feel like spending, you know, $400 a pop swapping out a bunch of pipes for probably really marginal differences. But in my book, if you want full performance out of your KTM, get the GET ECU and get a full open aftermarket pipe. The thing will rip. I'm telling you, rip. It's unbelievable. The extent to which I've been hours and hours on the bike. We did the Big Bear Trail ride. We did a couple of rides before. I just got off a weekend of riding here this last weekend and got hundreds of miles and dozens of hours on the FMF pipe. And every time I touch the throttle, it puts a grin on my face. It is that impressive. It is absolutely a monster of a bike. From the bottom end to the top end, it's everything that you thought you were buying when you got the 500, but that's been restricted because of smog requirements and other stuff. So it really turns this kind of mellow, sort of Prius feeling street bike out of this, the 500, and it gives you what you'd expect from a proper 500cc race dirt bike. So super impressive. I 100% will be leaving the FMF pipe on there. I'm extremely pleased with this performance. Now, there's theory and there's everybody's mythology, and then there's the practical application that we actually found riding this bike. So we ran through the theory. We showed you why we thought, or why we expected the full FMF pipe to actually deliver all across the RPM range, and why we didn't think we were going to take a hit in the mid-range or on the bottom end like a lot of people suspect you will. And then we went out and rode the bike, and you'll hear us commenting on the trail in a couple of segments that we shot about how we're experiencing that bike with that pipe on in the moment. But now that I've had so many hours on the bike and I sit here in the studio kind of thinking through all of that experience, I want to double down and reiterate to say that the theory absolutely matched up with practice. The stuff that we drew out on the whiteboard here a couple of weeks ago, and we were diagramming this thing out, showing you how those exhaust slugs move through the system and why it's, in our opinion, a complete myth that you're going to lose mid-range or bottom end. The funny thing is, we were out riding just this last weekend and actually hear guys saying stuff like,
I think my mid-range is a little bit lower, but I'm really happy for that extra horsepower on the top end.
I'm not sure what would happen if you put the bike on a dyno. I don't care to do that. I'm not a horsepower freak. What I want is a really rideable bike with accessible power. I want to hit the throttle and have really cool stuff happen. And that's absolutely what I got out of the FMF pipe, and I got it all through the RPM range. We crawled through parts of the Big Bear Trail Ride, for example, going up Malcolm Smith, going through boulder fields on Gold Mountain, crawled through, grunting the bike. I run in a high gear, which you guys watch my hill climb videos, you'll see I run a gear high. I like the way that torque goes to the rear wheel, so I'm lugging the engine way down in the bottom of the RPM range, at the bottom of the throttle range, and I had zero experience of any kind of loss of power at the bottom end. I honestly have no idea where that concept came from in terms of guys saying that that's what they feel. I felt nothing like that. From the minute you crack the throttle open to the very top of the RPM range, the bike absolutely screams. I felt gains all across the band. I felt a lot of luggable, low-end chug-chug kind of torque that you'd expect from a big bore bike, and I felt that screaming race horsepower at the top end for big hill climbs and stuff. I got it everywhere. I got everything I asked for, and I don't feel like I made any sacrifices to get there, except, of course, I paid a lot of money to get this stuff on the bike. But that's my impression, guys. Argue with me. Throw me a comment down below. Tell me what your experience has been, what your science is, what you've heard, what you think. I would love to learn something new from the whole process. I'm pretty confident in my own experiences because I know how I like to ride. I know what I like to see from the bike, and I'm super stoked with this pipe. There's a ton of mythology flying around there. There's a ton of pseudoscience. Everybody's got an opinion. It's like oil changes or tires, right? Everybody's setup's the best they've ever seen. And that's why I wanted to try all of these different components, right? And sort of walk through this process so I'd see for myself what each piece did for the system. And I will absolutely stand behind the full pipe. Again, I have no attachment to FMF. Any fully opened pipe should do the job. You're not sacrificing anything to go there. They look cool, they sound cool, and they deliver power all across the band. So that's my recommendation, guys. Super appreciate you guys taking the time to watch one of our longer videos here. We had a ton of fun putting this one together. Before I let you go, I want to do a quick shout out to the component that makes all of these videos possible, and that is the chin mounts that we make. I won't belabor the point, but we make these really cool chin mounts for a whole range of off-road helmets, enduro, MX, adventure helmets. These chin mounts are custom fit to every helmet style that we cover. We've got 40 and counting up in our shop right now. We're adding more all the time. Super strong, attached with 3M tape. They're not coming off if you put them on the right way. They're not damaging your helmet. You get that perfect chin point of view perspective. Anyway, tons of details available in our shop. Links down in the description. Check those out, guys. Of course, as always, we appreciate a like and subscribe, and we will see you next time. Thanks, guys.